Is your chance to get on the air. You can get on 100 radio stations and the internet by giving us a call and saying that, yes, the number to call is 612-564-8135, and ask that question that's always been bothering you. And remember that on Science Fantastic, we want to give you the information that will tell you about what the future might look like. Okay, let's move on now and take the next listener phone call.
Hi, this is Larry Chan, listening on GCN in Manhattan. I am on Chapter 2 of your book, Quantum Supremacy. I have a question about D-brains and P-brains. Can quantum computers calculate the shapes of hyperspace and cosmic topology? Is it possible to have a brain that's shaped like a Mobius strip, or a brain that's shaped like a Klein bottle? I would call these entities K-brains or kaleidoscopic brains. But do these entities really exist? Or what would a universe shaped like a Mobius strip be like?
Okay, well, you ask a question that's at the cutting edge of mathematics. So let me sort of explain how that works. String theory says that the universe is not just three-dimensional. We think that the world is three-dimensional with length, width, and height. Three numbers determine where you are in the universe, length, width, and height. However, along comes Einstein and says, no, you need a fourth number, and that is time. You have to give the time at which you make the measurement. Well, now comes string theory and says that there's not enough room in 4 dimensions to pack all the forces of the universe. There are too many forces. We need more room in which to expand all the forces of the universe, the nuclear force, the weak, the strong force. In 10 and 11 dimensions, we have enough room to do that. And what do we find in 10 and 11 dimensions? In 10 dimensions, we find strings. Vibrating strings that give us the proton, the neutron. Why do we have so many darn particles that you have to memorize to get a PhD? Well, it's because of the fact that we have enough dimensions to fill up. Now, once you go to 11 dimensions, however, something magical happens, and all the string theories collapse into one theory called M theory, and M stands for membrane. So we now realize that in addition to strings, there are vibrating membranes in string theory. This is called M theory. And as a consequence, it means that we have to think about what kinds of membranes might exist. So you mentioned Mobius strips, Klein bottles, so let me explain what they're all about. If I take a strip of paper and I fold it on itself, I get a ring. Okay, you got that? Take a long strip of paper, cut it, and then scotch tape the two ends together, and what do you get? You get a ring of some sort. Now let's make a twist. Before you scotch tape the two ends together, twist it once, and then scotch tape it together. And then what do you get? You get a Mobius strip. So a Mobius strip is an object that does not have two sides. Usually you think of paper having two sides, the front side and the back side, up, down. But if you twist the sheet of paper and then fold it together, then you get a Mobius strip. It's a one-sided object. Now you can do that with a Klein bottle. You can do that with a bottle as well. Let's say I take a bottle and I take the two ends. Let's say I take a tube. Okay, a tube. If I take a long tube and join the two ends together, what do I get? I get a donut. You got that? So a long tube whose ends are then joined together gives you a donut. Now, before you combine the two ends, twist it. If you then take a tube, twist the end, and then combine the two ends, what do I get? I get a Klein bottle. And then the question is, are these suitable universes by which you can then make computations? Well, believe it or not, we physicists try to catalog all these different possible universes, including Klein bottles, including Mobius strips, including all the different kinds of objects that Mother Nature has created in the world of pure mathematics. And we think that each one could be a universe. This gets us into a multiverse of different types of universes. Why should our universe be the only one? In other words, if the Big Bang took place in 11 dimensions, and as it expanded, it curled up. There are many ways to curl up. And that clutters the field for possible universes, but hey, that's the theory. And so in other words, string theory gives you a multiverse of universes. And so some people say, well, of what use is a multiverse? We think that string theory gives you not one universe, but a multiverse of universes. Now, some people think that's a defect in string theory, that instead of giving you one universe, this is our universe, here it is, folks, a unique prescription for our universe. String theory gives you millions of possible universes, because there are millions of ways in which you can chop up an 11-dimensional membrane and compactify it, as we call it, down to 4 dimensions or 3 dimensions. So, why did Mother Nature select out this universe? Well, we don't know, okay? This is called the landscape problem. I have a landscape of possible universes. Only one of them fits the universe that we see around you. That in itself is a miracle. If we had just given you string theory and told you that it can give you our universe, that would be incredible. But the problem is, it gives you not just our universe, but it gives you all these other possible universe, Mobius strips, Klein bottles as well. So what's the moral of the story? The moral of the story is, if you ever find out why our universe is special among this landscape of universes, you should tell me first. Tell me first, we'll publish together, and we'll win the Nobel Prize together, you and me. Okay, well, that's Science Fantastic for today. Once again, the book is